Hello, I'm Matt Wynne. I'm from the Cucumber Project and I'm here to talk to you about behavior driven development, what it is, and why I think you should care. A little bit about me. I am an independent consultant and coach. I am the co-lead of the Cucumber open source project, which was downloaded over 100 million times this year. We think it's the world's most popular tool for practicing BDD. And it's free and open source. You can read more about me on my website, mattwynne.net. So let's talk about how software starts, right? Software starts as an idea in someone's head. And maybe they're lucky, maybe they have all of the skills to turn that idea into working code. But that's pretty rare. Normally, software projects have to involve multiple people. And the issue we have is that when we want to involve multiple people, we're going to have to communicate that idea to all of those people. And usually it doesn't work out like this. Usually what actually happens when we try and transmit an idea from one person's mind to other people's minds is that everybody sees different things in their heads. And really what we're talking about here with this problem is two really distinct groups that need to be able to communicate but often don't. On the one hand, we have the stakeholders with problems and resources to, or money, let's say rather, to solve those problems. And then on the other hand, we have the solution domain experts, the programmers and the testers who could fix those problems. And if these two groups can communicate effectively, everything goes well. If they don't, not so good. And we can characterize these two groups as coming from two different domains. There's the problem domain and there's the solution domain. And let's start by focusing on the problem domain. When we think about doing BDD, we really think about three steps. We start with doing some discovery, where we really look at the problem domain and understand the problem domain. And then we do formulation, so we try and document our understanding of a small piece of the problem domain that we're going to implement in software. And then we do automation to actually turn that into code. And let's start with the discovery part. Why do we need to do discovery? Well, if you think about the process of working through a software project, you're kind of always working along this emergent horizon. You right here in the present, you have these things that you know about, that you know you need to get on with. And probably in the near distance, you know that there are some things that you don't really understand very well. But further away than that are the things that you don't even know you don't know yet. And everyone who has been on a software project knows that those unknown unknowns, those surprises, are some of the most significant factors in the success of your software project. The stuff that you know right now, sure, it's useful, but the stuff that you don't know yet, that's the stuff that can really trip you up or sometimes make a real difference, like you discover a really amazing opportunity. So what we talk about a lot in BDD is kind of accepting this as reality, right? Not assuming that we know everything. In fact, assuming the opposite. Assuming that we're ignorant. We come from this position of assuming we're ignorant and we're actively hunting all the time for what's the stuff that we don't know yet. And one of those practices we can use is the three amigos, where we involve testers, product owners or business analysts, the domain experts, and programmers together in a conversation before we start work on any user story. And a really good pattern for that conversation can be something called example mapping. But we're not going to get into details about how to do that yet, but those are some pointers for you to think about. Let's move on to the second practice of BDD. So let's say we've had that conversation and we've taken a single user story, a few days of work. We're not talking about big chunks here. We've talked about it. We've done some discovery work. We understand the scope of it now. We've narrowed it down and made it as small as we can. What do we do next? Well, the next thing we do is what we call formulation. And in formulation, we're going to try and specify by writing down the details of the behavior of the software for this small piece of functionality. And we're going to review the way that we've written down that specification, the way we've expressed it with domain experts to make sure that it reflects our understanding. And this comes with a couple of benefits. One benefit is it's way cheaper to write a few lines of what we call gherkin specification. I'll show you some of that in a minute. It's way cheaper to do that and review that than to write the actual working software. Right? Working software is really expensive, but sketching out some gherkin scenarios is much, much cheaper, but it can be a really good way to simulate what that code would do, and give people a way to get their heads around what it might do and whether that's actually what they want it to do. The other thing we get from doing this is we start to discover our ubiquitous language. We start to discover a domain language that we can use to communicate about the project, the words we're going to use to communicate about the project. And those are words that we can then use all the way down in the solution domain. So what we want is for our solution domain as much as possible to map to the problem domain and be a reflection of the problem domain. We're building a model of the real world in our software. And the more we can use the same words as we would hear in the real world where people are working in that problem space in our solution, the easier it's going to be for us to communicate with the people who really understand that problem space and make sure that we're building a solution that's going to work for them. So what does gherkin look like? Here's an example. So we use these scenarios grouped into features. Each scenario is a chunk of behavior. It's an example of what the system ought to do. Given some context, when I have some interaction with the system, then this should be the outcome. And you can see here how these are really easy for people to read, but they're also super explicit and concrete. And that really helps people to visualize what the system's going to do, really think about it, think it through. But it's also going to help us when we come to doing automation, because a tool like Cucumber can take these examples and it can run it as an automated test against your system. So we've done some discovery, we've done some formulation, and now we're going to do some automation. And why do we want to do automation? Well, one thing to think about when we're doing automation is we take these small scenarios, each of which describes one tiny aspect of the system's behavior, and each of them is something that we can implement and test independently. And that means that we've really ground up the problem into these tiny little pieces that we should be able to deliver in a few hours, maybe a day or two. They're really small pieces of functionality, which really helps us to flow as a team. So, for automation, we're now moving into the solution space. And I want you to think for a minute and imagine that your solution domain, your code base, was instead of a code base, what you have is a restaurant, right? So instead of features being delivered, you have meals being given to customers in the restaurant. Instead of chefs in the kitchen, you have programmers, right? Instead of programmers, you have chefs in the kitchen. And, instead of refactoring tools and IDEs and terminal prompts, you have knives and pots and pans. So your software project, your software product, your team is a kitchen. Imagine that restaurant kitchen. Just visualize it for a minute. Like, what does that restaurant kitchen look like in your mind's eye? Does it look like this? Or does it look more like this? Because so many of the software projects that I've worked on and I've seen, when we get into the code base, when we walk into the restaurant kitchen, it's a mess. And it's really, really hard to tidy up your mess if you don't have good automated tests. It's really hard to deliver on the promise of agility, to keep changing the code, to match what the business wants it to do unless the code is clean and neat and tidy, right? It's going to be very hard for you to keep on producing great healthy meals from that kitchen unless you keep the knife sharp and you keep the counters clean and you keep cleaning the pots and pans. And just in the same way, we have to tidy up the code base. But it's really difficult to tidy up a code base unless you do refactoring. And refactoring is a process of changing the design of the code without changing its behavior. So we want to be able to manipulate and move code around, but we want to make sure it still does the same thing as it did before. And it's really difficult to know whether the code does the same thing as it did before unless we've got good automated tests. So we really want to be able to rely on automation. And here's how the process of test-driven development works, which is really the heart of behavior-driven development, right? When we talk about BDD and TDD, test-driven development, we're really talking about the same thing. It's just a different way of expressing that test as something that's human readable, which is going to connect better with members of the team, stakeholders in the team that can't read code. But we're still talking about the same process. We start by writing a failing test. We describe what we want the system to do, but it doesn't work yet. It doesn't do that yet. We wire it up so that we see it fail, and then we make changes to the system until that test passes. But we're not done yet, because now we've got to sharpen our knives, we've got to clean up the pots and pans, we've got to wipe down the counters. So the third piece of this process is to clean up. And if we do that, if we keep doing that process, we're going to be able to work at a sustainable pace. So finally, after all of this, what we end up with is what we think about as living documentation, because we have these artifacts, these Gherkin documents, which are readable, but they're also continuously verified by being able to run them and execute them against the system to tell us whether they're actually telling us the truth. So, in summary, what is BDD? It's using examples to drive conversations, using those conversations to grow the team's domain knowledge and their domain language, and then it's using automated tests of those examples to drive the development and to protect you from regressions in the future and allow you to refactor the code and keep it clean to keep that cost of ownership of the software under control over the medium and long term. And it's also going to enable you to enjoy practices like continuous delivery, because if you have good test coverage, you're going to be able to ship changes into your production environment in a matter of minutes with complete confidence, because you know that the software is doing what it's supposed to. And that's an investment, but it can be a really great investment. All right, thanks for listening. You can find me again at mattwynne.net. I hope this presentation has been useful. Thank you.